Welcome back friends. Today we are going to solve LeetCode problem 62 unique paths. So before we start looking details of this problem, please subscribe to my channel. I often create good videos about LeetCode Java solutions and Java J2E related interview helpful videos. So please subscribe to my channel. It helps the channel to grow. So let's look details of this problem. So a robot is located at the top left corner here of a m by n grid. So this one is a 3 by 7 grid, right? 3 rows and 7 columns. And the robot can only move either downwards or right at any point in time. The robot is trying to reach the bottom right corner. So robot want to reach here. How many possible unique paths are there? So we have to find out the possible unique paths. So let's just take this example over here. So for example, what is a possible unique path means one of the possible path is like this, like a robot can go rightward and then downward. So this is one possible path. Other possible path is a robot can go downward and then all the way towards right, so it will reach the finish, right? So we have to find out all the possible paths that are there in this matrix, right? So we are going to use a technique called as dynamic programming, where we will form a DP array. So our original matrix is given is a m by n matrix, right? So m rows and n columns, which is 3 rows and 7 columns right here. So what we will do is we will in the beginning create a DP array, and DP array is again of the same size of the original matrix. So this is our DP array, and it will be 3 by 7, right? Means m by n. Basically here m is 3 and n is 7, so we created 3 by 7 DP array, and in the beginning everything will be 0 in this array, right? So now the robot is allowed to go either towards right side or down side, right? Other directions are not allowed for the robot to go. So if robot is starting from this position and want to reach this cell, it can go like rightward and it will reach here, right? So there is only one way to reach here, only one path is there to reach to this cell. Similarly, if it goes straight again on the right side, then it will reach this cell. So there is only one possible way to go here, right? Like this, if robot goes straight, then only it will reach here. So it is one way only. Similarly, for these cells, there is only one possible path to reach to this cell for the robot, right? Like going right, basically. So this is the way we will be populating the first row of the DP array. So as you can see, we have populated here first row. All the values will be 1 because there is only one way to reach to this cell for the robot. Basically, as I explained, right, it will just go rightward and it can reach to this cell. Similarly, if robot want to go and reach this cell, it has to go downward, right? So there is only one way to reach to this cell, and there is only one way to reach to this cell. So we have just marked this as a 1 for the first column, right? So we have populated the first row and first column of the DP array, right? So now we have to populate the DP array for the remaining cells, right? So how we can populate the DP array is, whenever we are at any specific cell, we have to get some of the diagonal cells. So for this cell 2, the diagonal cells are these, right? These are the diagonal cells. So as you can see, it is 1 plus 1, that is equal to 2. So similarly, for this cell, the diagonal cells are these cells, right? 1 and 2, these are the diagonal cells. So it will say 1 plus 2 is equal to 3. Similarly, we can calculate 4. 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7. So we have populated this row, right, all the way. Similarly, we can start now populating the last row this way. So this is the cell we are looking at. So we will have to get the diagonal sum of these cells. So 2 plus 1 is equal to 3, right? So we just put 3 here. So 3 plus this 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, and 21 plus 7 is equal to 28. So our last cell that we got for this DP array is a 28. So 28 ways are there, unique ways are there for the robot to reach to the last cell, right, from the start point. So if you look at the answer, then it will be 28, right? So this is how the 28 came from. So we will populate the DP array gradually. First we will populate the row and the first row and first column, and then we will populate the remaining cells. So let's take a look into the details of the of the solution that I have here. So let me just quickly show you that code. So as you can see here, first we have created an empty matrix because we have been only given m by n size. So we just create an empty matrix here of the size m by n, and we are passing it that matrix to our total paths method. So total paths method is this one, and we will just get the m and n here, which is size of the matrix, and we have created a DP array of the same size here, right? And then as I said, we will be just moving like downward. There only one way to go to the downward, so we are populating first column here, right? I0 means it will go like all the rows go from 0 1 2 3 like that. So DP of the first column will be 1, and DP of the first row also we populated as 1, right? So that's what I explained here, all these ones and all these ones. So that's what we are doing here, and then we will iterate through remaining cells. So remaining cells will obviously start with a 1 1, right? So I is 1 and j is 1, because first row and first column we are already done. So now we are doing the remaining cells. So what we will do is we will get the sum of the diagonal cells basically. So for every cell, this is the diagonal cell. For example, for this cell 2, if we are looking at this cell 2, then these two will be the diagonal cells here. 1 1, this is the diagonal cell. So in the logic we have said that I minus 1 j and I j plus 1. So this is what we will do the summation, and we will assign it to dp ij basically, and at the end we will just return the last cell basically, which is rightmost cell, right? So if let's just execute this code once and make sure this is working. So 3 by 7 is given us, which is 28, and we will take 3 by 2 also, the other example that they have given us. So we will just run the code quickly and make sure our code is working fine with this. So we got 28 as I explained here, right? 28 ways, and for the other one we got 3, which is also correct, right? 3. So now we will submit the code. So the code is 100% faster. So this is maximum like faster code, right? So this is the way you can solve the unique paths for Robert from start to end using a dynamic programming approach. You can just create a dynamic programming array, and you can first populate the rows, this row, first column, and then you can populate the remaining cells, right, using the diagonal summation of diagonal cells. So as I said in the beginning of the video, I often create LeetCode solution videos using Java and Java J2E interview related helpful videos. So please subscribe to the channel. It's really important for the channel. So please subscribe. Thanks for watching the video.